Hi everyone, in this video we're going to discuss our test here. Given that we have two complex number, we need to express this in the standard form, means we simplify this operation. Then given that A, B are real number, you need to find the modulus and argument of the m and express the complex number m in polar form. So firstly, m it is equals to conjugate of complex number 1 plus 2 the second complex number over the first complex number 1. Then this is the second complex number conjugate. So we substitute here complex number conjugate. The first one, it will be 2 plus 4i. Then plus 2 times the complex number 2, negative 3 plus 5i. Then over the first complex number 2 minus 4i, and then time with the conjugate of second complex number, which is negative 3 minus 5i. Alright, so we simplify first the denominator and numerator. This is 2, and then expand minus 6. So 2 minus 6 will have negative 4. And then 4i plus 2 times 5, 10. 10i plus 4i, we get 14i. Then we expand, we do the multiplication complex number at denominator here, we expand, we have negative 6, negative 10i, and then multiply this, plus 12i, and then plus 20i squared. So I squared, we can simplify it to be value of negative 1. So lastly, our denominator here, our real part will be negative 6, negative 20, so negative 26. The imaginary part here, plus, minus, we have positive 2i. So now you can notice that our complex number is in division. So when we're doing the division of complex number, we need to time with its conjugate. So its conjugate will be negative 26 minus 2i. So as we have complex number time with its conjugate, z times z conjugate, it will be a squared plus b squared. Here we have a squared negative 26 squared plus b squared, which is 2 squared. So for numerator, we expand 1 by 1. 4 times this. Negative, negative become positive. And then 4 times to the back, positive 8i, and then 14 times negative 26. So we have negative 364. And lastly, we have negative 28i squared. So again, simplify I squared here to be the value of real number, negative 1. So we will have here 26 squared plus 2 squared. Denominator 680. Numerator here, so here we have I here, alright. So numerator 104, negative, negative, positive, it become plus 28. So 132, imaginary part 8 minus 364, negative 356i. Simplify to until we get standard form. So 132 divided by 680, you get 33 over 170, and then 356 divided by 680 for imaginary part, you get negative 89 over 170i. So when you're dealing with these questions, you're afraid that you do some mistake and then getting wrong, it will affect your question after that. Actually, you can check your answer with your calculator. So just set your mode to complex number. Then we simplify. We press our questions here, which is 2 plus 4i. I will be happening here. And then plus 2 times negative 3 plus 5 pi. Then divide by 2 minus 4i. Just have a check so that your operation here you get a correct complex number in order to continue for the rest of the questions. So equal, alright, so this is our real part, this is our imaginary part. So this is our complex number where we simplify it into standard form. Now we can continue. Hence, find the modulus and the argument. So modulus of m, it will be square root of a square plus b square. Okay, so square root, put in the bracket here, 33 over 170 square plus 89 over 170 square. So here we have, it automatically gives us the decimal, so we remain it in decimal, 0.558. Make sure you have more than 3 significant figure. So 83 round off become 84. I give here is 4 significant figure. Then continue, we want to do for the argument. So for doing argument, we need to draw out our Argand diagram and express it in the polar form. So our Argand diagram, x-axis is real part, y-axis is imaginary part. So real part here, 33 over 170. Y-axis here negative, so negative 89 over 170. So here we have our complex number is in quadrant form. Then to find its argument, let us see our notes. If our complex number in quadrant form, its argument will be equals to negative alpha. So negative alpha. Alpha will be equals to, alpha is our basic angle. It will be equals to shift tangent in the bracket of b over a. And b and a here is a length. Length that denoted here will be in positive value without negative. So shift tangent in the bracket, value of b without negative value over 170 b over a. So what else that we need to be careful here, where our argument must be in radian. So shift mode, change it to angle unit for radian, then only you can do your shift tangent. Put in the bracket of fraction first. So this is the way how we key in our calculator fraction over fraction. Put in the fraction in the setting of fraction here. At the denominator again, we press out the fraction form so that you will not misunderstand which one is your denominator, which one is your numerator. So at denominator, we press our fraction form. It will be 33 over 170. So here we have negative 1.2157 radian. Then lastly, we express this complex number in polar form. So expressed in polar form, we will start with modulus 0.5584 in the bracket cos theta plus I sine theta. Alright, so this is our polar form for our complex number. Then we move on to our second questions here, where this is our indices. We have our indices equation. So first, when we're dealing with indices equation, you have to check whether it can be a single or not. So how do we know the indices can be single or not? Only the operation times and divide, we can make it simplify to 1. So or not, if you don't have, we just let the question. So you can see this is our indices, this is our indices. It is in the operation of minus, which means that it cannot be single. If you can be single, means the operation should be times or divide. So when it cannot to be the single indices, we need to apply our method of let. So just let our indices here, we have 64 power x and 8 power x. Let the simplest indices that we have will be 8 power of x. So 64, we change it to base 8 power of 2x minus 5 8x plus 4 equals to 0, so that we can let in this is m squared minus 5m plus 4 equals to 0. When we get a quadratic, we do factorize and we find your x and we substitute back our indices that we let just out. Then we can solve, means we can find the unknown x here. So we factorize. So we have m equals to 1, m equals to 4. So what is our m here? Substitute back, which is 8 power of x. So to get x, how to get x here? If you can get it to the same base, yes, we change it. If you cannot, you just log it. So you can just log 8, 1. Alright, power move down, your base move opposite, become log base. Then you can press your calculator. So this one, log in the base 8. Then for the value 1. So you can get this one is 0. X is equals to log 8 for the value of 4. This is 2 over 3. So for indices, we don't need to check answer. It can accept any value of x. So this is our final answer. Then we move on to inequalities. So when we have inequalities, modulus inequalities, we can do squaring both sides. Alright, so our method should be applied here, will be squaring both sides. So square root modulus indicate that, change it to square root and square. So this modulus will be square root of 2x plus 5 squared. Then square root of 3 minus 4x. So only modulus both sides in inequalities, we can do squaring both sides. Other than that, we cannot. We have other method to use. So squaring both sides, then square root and square can be simplified. Leaving inside here will be 2x plus 5 squared. And then this is 3 minus 4x squared. Expand this. Alright, so when we expand, bear in mind, a plus b squared, it will be a squared to ab plus b squared. So a squared for x squared, 2ab, 4 times 5, 20x, then 5 squared, 25, greater than, again square it again, 9, then 3 times 4 times 2, and then 4x squared. So 4 squared, we get 16x squared. So now we will have our quadratic inequalities. So how we do our quadratic inequalities? Let us revise. So quadratic inequalities, rearrange all the terms to the left hand side. Let your right hand side greater than 0 or less than 0. Then you need to simplify your quadratic, means you have to make sure your ABC coefficient in the simpler form, in the smallest coefficient, and your quadratic must be in positive. Then doing factorize, drawing the graph and shape your region. So when I move this to the left hand side, it gives us negative 12x squared plus 24 minus 9 you can notice that our quadratic is negative and our quadratic can be simplified. So we divide by negative 4. So when we divide by negative 4, here we have 3x squared. This is negative 11x. So this is negative 4. When you divide by negative, change sign. Then only we can start factorize. So 3x. 1 with 4, we have negative and plus. So our next step here will be, after we factorize, is drawing the graph. We use quadratic graph method. So what is our roots here will be arranged in order, the smaller value at left hand side, bigger value at right hand side. When you have less than 0 means the region below x-axis, the negative region, which is below x-axis. So with that region, so this is your answer. Your x, negative 1 over 3 is less than x, and then less than 4. Got equal or not? Then we refer our question. Our question do not have equal. And what kind of pattern of the answer we should write? We should give our answer in set form. So put your set notation. So this is our answer in set form. Alright, then we continue. Solve our log. So let us revise log. For log, what's supposed to do? For the first thing, make it same base. So our question, base 2, base 2, base 2, already same base. Then you have to move on. Second consideration, can be single or not. If you want to make it single, you have to observe if operation plus minus can be single. If you have times, you have your division, it cannot be single. So you look at here, log plus log means it can be single, means it can be one log only. So how to make it single? So log plus log, make it single log, the item, make it multiply together, put it in the bracket. So this is x times x minus 4. So our left hand side become a single log. Our right hand side already a single log, so we just maintain. So when we have both sides single log, both sides already single log, here one single, then we can, what can we do? We equal the item. So which means that x times x minus 4 will be equal to x plus 24. So we equal the item. So after we equal the item, what can we do? Continue, we just solve. So solve it. So this is our quadratic equation. We solve it. X squared minus 4x. Move it to the left hand side. Then x squared minus 5x minus 24. So quadratic, we need factorize to get the x. So press your calculator to get your x. So negative plus, so your x is positive 8 and negative 3. And what is that? Continue. You remember you need to check your answer. So in topic 2, indices, no need check answer. Cert, yes, you need to check left hand side, right hand side. Log, you need to check answer. This is log positive. What else? You also need to check your modulus equation. If you come to inequalities and absolute, so you need to check your answer in your equation. Don't forget here, check your answer, modulus equation, you need to check. So most of them, all the equation need to check answer, just except indices. So how to check its validity? Try, look at here. So put your x back into question. Make sure log bring the positive value. So when I put 8 inside this is positive value. 8 minus 4 also positive value. 8 plus 24 also valid. So this valid, this 8 value of answer 8 is valid. So check for negative 3. Negative 3 when I put here, so log negative 3. So this is invalid. Therefore, we have to conclude out. Now we only have one answer. X equals to 8, which is valid. So this one invalid, we need to reject the answer. Alright, so that's all for this test. Thank you for watching.